The fate of the SB aircraft with Hispano-Suiza engines turned out to be much better than that of its predecessor with radial engines. By May 15, 1934, the construction of a prototype of this SB variant had begun. It differed from its predecessor not only in engines but also in some dimensions. The wingspan increased to 66.7 feet, and their area grew to 569 square feet. The area of the tail assembly also increased. The volume of fuel tanks nearly doubled. The takeoff weight reached 10,692 pounds and the maximum 12,187 pounds. The new aircraft was equipped with two Hispano-Suiza engines with 780 horsepower each. The propellers were two-blade metal with fixed pitch. The propeller hubs were covered with small spinners. The shape and dimensions of the engine nacelles resembled the previous model, but the front of the cowlings had an oval rather than a round shape. Engine cooling was provided by frontal cellular radiators. At the front, they were covered with horizontal shutters, and at the outlet, the airflow was regulated by rotating flaps. The aircraft was assembled by New Year's, and already on December 30, 1934, pilot Zhurov made its first flight. The takeoff was performed on wheels. After hearing the report of CGI head Kharlamov on the results of work for 1934, the aviation leadership stated, CGI achieved a number of major accomplishments of world significance in the field of aviation technology, contributing, along with strengthening the country's defense, to the transformation of our aviation into the best in the world. In the field of experimental construction, TCGI solved the problem of high-speed bombers. In particular, TCGI fulfilled the following government task. The SB with two Hispano engines. The high-speed bomber was designed and built according to the same scheme as the SB with radial engines, but with somewhat different aerodynamics. At factory trials, it demonstrated very high flight qualities. Its speed of 269 miles per hour is higher than many of the world's best fighters. This aircraft was built from super duralumin using new technology, smooth skin, flush riveting. This creates an enormous breakthrough in Soviet aviation and the aviation industry. Factory trials continued until February 6, 1935. Outstanding results for the time were achieved. The maximum speed at an altitude of 13,123 feet was 267 miles per hour. The climb rate of the aircraft was also noted as quite good. For joint trials between the Design Bureau and the Air Force, by January 23, a crew from the Research Institute was assigned. It included pilot Minder, navigator Brian Jinsky, flight observer timekeeper Noldy, and technician Obodenikov. On February 8, 1935, joint trials of the SB began at the Air Force Research Institute. By the conclusion of the tests on February 19, 38 flights had been performed. In addition to Minder, pilots Gromov, Phelan, and Yumashev participated in the aircraft tests. From TCGI, Zhurov's crew took part. The trials were carried out with skis, which were not retracted in flight. The maximum speed on skis was, near the ground, 199 miles per hour at the rated altitude of 13,123 feet, 218 miles per hour at 26,247 feet, 193 miles per hour. Time to climb 16,404 feet, 7.2 minutes. Practical ceiling, 30,140 feet. An outstanding result for its time. It was expected that in summer conditions with retracted wheel landing gear, the maximum speed at rated altitude would reach 261 miles per hour. The takeoff weight of the aircraft was 11,023 pounds. Wingspan, 66.6 feet. Wing area, 509.7 square feet. Accordingly, the wing loading was 21.6 pounds per square foot. Engine power near the ground, 1530 horsepower, and at the rated altitude for the engines of 10,171 feet, 1720 horsepower. Accordingly, the power loading near the ground was 7.2 pounds per horsepower, and at rated altitude, 6.4 pounds per horsepower. The aircraft's center of gravity was 29.3% of the mean aerodynamic chord. The state trial report noted that the SB had not passed the trials. Nevertheless, it was recommended that the aircraft be adopted into service, put into series production, and its shortcomings corrected. By March 15, 1935, its armament and equipment were to be finalized. The main shortcomings were noted as insufficient longitudinal stability of the aircraft, insufficient aileron effectiveness, inadequate rudder control during flight on one engine, and imperfections in the engine cooling system. The conclusion stated that the SB belongs to a new tactical class of modern bomber aircraft, possessing extremely high horizontal flight speed and rate of climb. On March 3, 1935, the SB suffered an unexpected accident. The pilot was testing speed at low altitude. Suddenly, when the aircraft accelerated to 230 miles per hour, the wings began to shake violently and the control stick started to be torn from the pilot's hands. Pilot Minder held the controls with all his strength, sharply raised the aircraft's nose upward to reduce speed, and then went for landing. After landing, it was found that the wing skin had bulged due to dangerous wing vibration caused by improperly adjusted ailerons, the wing parts controlling the aircraft's roll. This phenomenon is called flutter. It was known theoretically, but Soviet aircraft construction had never before encountered it in practice. A group of TSAGI specialists, including future academician M.V. Keldysh, worked on methods to combat this problem. They recommended changing the aileron settings to achieve a weight balance of 90 to 93%. The aircraft was under repair for a whole month. Before submitting the aircraft again for state trials, TSAGI decided first to check how well the modified ailerons worked and whether dangerous vibration would reappear. The test flight was entrusted to pilot Jurov. The flight was carried out under the personal supervision of designer Arkhangelski. In the air, the aircraft accelerated to 249 miles per hour. No vibration appeared. After hearing the pilot's report, A.N. Tupolev, present at the airfield, hastened to inform the leadership that flutter on the SB has been overcome. During the repair, changes were also made to the tail section of the aircraft. The stabilizer area, the horizontal part of the tail, was increased, a small fixed plate was replaced with an in-flight adjustable trim tab, and the stabilizer installation angle was reduced by 1 degree. All these modifications were intended to improve the aircraft's stability in flight. However, it turned out that the improvement in stability was insignificant. In addition, a new problem appeared: engine overheating in summer conditions. At an air temperature of plus 106 G, the engines overheated so badly during taxiing that normal takeoff became simply impossible. The measures taken produced no result. On June 16, 1935, the SB was once again transferred to the Air Force Research Institute for the second stage of state trials. They were conducted by Minder's crew. A maximum flight speed of 251 miles per hour at an altitude of 16,400 feet was recorded. The aircraft demonstrated good rate of climb and a fairly high maximum altitude. However, the test report noted the following shortcomings: underdeveloped engine installation, insufficient stability of the aircraft in longitudinal and lateral directions, and a tendency to tilt during acceleration. The upper gun turret, due to insufficient rigidity, caused wide bullet dispersion during firing. Vibrations of the engine mount frame, transmitted to fuselage elements, were also discovered. The aircraft also had significant operational shortcomings. For these reasons, the aircraft did not pass the state trials, and on July 18th it was returned to TSAGI for further modifications. During the modifications, quite a number of changes were made to the machine. The engines were moved forward by 4 inches, and wings with increased sweep along the leading edge were introduced. This ensured a more forward center of gravity for the bomber. The stabilizer area was increased, and its installation angle was changed. The wing dihedral angle was increased. Mass and aerodynamic compensation of the rudder, elevator, and ailerons was introduced. The vertical tail took on a more rounded shape. On September 23, 1935, the SB bomber was once again transferred to the Air Force Research Institute for additional state trials. In total, 308 flights were carried out, with total flight time reaching almost 75 hours. The main tasks for eliminating the shortcomings noted in the report were considered the following: increase the safety margin to the required standards, increase the durability of skis to at least 300-350 landings, reduce and completely eliminate the tendency to overturn, especially during landings on soft soil and loose snow cover, improve engine cooling at outside temperatures of 68 Brennerdieers and higher, increase durability and reliability of generator drives, eliminate the shortcomings of armament and special equipment noted in the report, improve maintainability by facilitating access to parts subject to rapid wear and frequent inspection. It was further necessary to extend the normal operational range of the machine without reducing useful load to at least 745-930 miles, and the maximum speed to 280-300 miles per hour. In addition, it was planned to increase the strength margin to 8 to 9 times in accordance with existing strength standards, as well as the bomb load to 1,650, 2,200 pounds by correspondingly reducing the dead weight of the structure. The test conclusion stated, "The SB aircraft, as already noted by the Air Force Research Institute in the reports on the state trials of February and June 1935, belongs to a new tactical class of modern bombers. Its high flight characteristics and fairly powerful armament ensure tactical independence and speed of action. In particular, tests of aerial combat established that the SB can use its speed to escape from attacks by the I-15 type fighter. Its maximum speed at the rated altitude of 9,800 feet was 228 miles per hour. Leaving behind a strong air wake 490 to 650 feet long, the aircraft disrupts the pursuing fighter formation, spoiling their aim fire at these distances. Thanks to its camouflage coloring, the SB is well concealed against the snowy surface of the ground and against clouds, greatly complicating fighter attacks and ground observation. Compared to the previous prototype that underwent state trials, this model has the following advantages. Aircraft. Longitudinal stability significantly improved, stable up to 32% of the mean aerodynamic chord. The previous prototype was stable only up to 29%. The strong left roll at high speeds was eliminated, and increased rigidity of the center section eliminated skin deformation. Route flights in adverse meteorological conditions are possible, since the equipment and stability of the aircraft path allow instrument flight. Flight on one engine is possible for a long time and at significant altitudes up to 16,400 feet. In this case, the aircraft retains considerable maneuverability. Increased rigidity of the engine mount frame improved operational reliability. Armament. The machine guns of all gun mounts, as well as the mounts themselves, operated flawlessly on the ground and in the air at outside air temperatures down to 40°F. Easy maneuvering of the paired machine gun mount within permissible firing angles was possible at speeds up to 174 miles per hour. Horizontal bomb racks up to an altitude of 26,600 feet and at outside air temperatures down to 60° operated flawlessly. The mechanical system, emergency release, and hatch control mechanism function normally at all altitudes and flight modes. The electromechanical devices with heating and electric pyro cartridges installed on the bomb racks worked flawlessly at temperatures down to 63 degrees and altitudes up to 26,900 feet. Electric pyrotechnical releases provided more reliable operation as they were simpler in design and operation and consumed less electrical energy. As the main shortcomings of the aircraft, military specialists noted the following. Aircraft. Static tests were not conducted, which so far excludes the possibility of flying this aircraft with increased load, and therefore limits the ability to extend its range and restricts maneuverability at high speeds. Armament. Reliable operation of machine guns at sub-zero temperatures was not ensured. The turret, when rotated at flight speeds above 174 miles per hour, required considerable effort from the gunner. The gun sight failed at altitudes above 19,700 feet and at outside air temperature of 22 degrees at lower altitudes. Special equipment. The intercom worked unreliably. Microphones froze. Operation. It was noted that the aircraft was difficult to maintain. Servicing, inspections, and minor repairs required a lot of time. Replacement of individual engine units required prior removal of other components and parts. The final report on the SB trials stated, "The SB aircraft is to be considered as having passed the state trials. It is considered necessary to oblige the main directorate of the aviation industry to continue work on eliminating the detected defects and on further modification of this aircraft type. At the Air Force Research Institute, a full study of combat employment of the SB aircraft is to be conducted." The conclusion was signed by Air Force Research Institute head Kombrig Bajanov, head of the First Department of the Institute Petrov, head of the Central Aero Hydrodynamic Institute Karlamov, and head of the Institute's Experimental Flight Department Chesilov. The report was approved by Air Force Directorate head Ya I. Alksnis on February 14, 1936. It should be noted that the trials and modifications of the SB aircraft with new engines dragged on for a very long time. They lasted more than a year. However, it must be considered that this aircraft was fundamentally new for its time. It was developed by a young team that had not yet accumulated sufficient experience. At the same time, the main difficulties faced by Arkhangelski's team, stability and controllability in flight, as well as effective engine cooling, were typical problems of all Soviet aircraft of that period. Meanwhile, the main aviation institute could not for a long time develop effective recommendations on these issues. This was repeatedly pointed out by Air Force leaders Phelan and Smushkevich. These problems were first truly solved on the aircraft of Sukhoi and Polikarpov. After the completion of state trials, the SB with new engines was handed over as a prototype to Plant No. 22, where serial production of SB aircraft was already underway. In layout, the new SB practically did not differ from the version with the previous engines. The main structural part of the SB's body consisted of the central wing section with engine nacelles and the central fuselage section, structurally connected into one whole. To them were attached the detachable wing panels, nose, and tail sections of the fuselage. In the forward fuselage was the navigator-gunner's cockpit, who also served as the bombardier. Behind it was the pilot's cockpit, then the bomb bay, and closer to the aircraft's tail, the gunner radio operator's cockpit. The bomb bay was located in the central fuselage section. The mid-wing layout, with spars passing through the bomb bay, determined the bomb suspension scheme. The maximum bomb weight was limited to 1,100 pounds. Large bombs weighing 100 Nashorn and 550 pounds were suspended in the bomb bay horizontally under the wing spars. Bombs of lesser weight, from 220 pounds and less, were suspended in combination, vertically in the forward part of the bomb bay between the wing spars and horizontally in the rear part behind the rear wing spar. Since the entire bomb load of 1,320 pounds was concentrated near the aircraft's center of gravity, its release did not significantly affect the aircraft's stability and controllability. Bomb release was controlled by the navigator using electrical and mechanical release systems. In the pilot's cockpit, there was a duplicated emergency mechanical release. For bomb suspension, 2 winches mounted on a special removable frame were used. To repel enemy fighter attacks, the SB aircraft was equipped with 3 gun mounts developed at the plant under Shebanov's supervision. In the navigator's cockpit was a protected gun mount with a pair of Shkaz machine guns, total ammunition 1,000 rounds, which moved only in the vertical plane. At the same time, due to bullet dispersion during firing, a small cone of fire was formed in the horizontal plane. In the gunner radio operator's cockpit were 2 movable gun mounts with Shkaz machine guns. The upper mount was a TUR-9 turret, ammunition 760 rounds, and the lower, a hatch mount, ammunition 500 rounds. The TUR-9 provided fire in a cone in the upper rear hemisphere and the hatch mount in the rear lower hemisphere. In stowed position, when there were no enemy fighter attacks, the guns were retracted inside the cockpit. It should be noted that the TUR-9 at that time was the most original turret for the high-rate Shkaz machine gun, which to a large extent solved the problem of conducting aerial fire in all flight modes of high-speed aircraft. Currently, the TUR-9 is the only turret that allows firing during turns and other types of overloads. This is achieved by balancing the weapon with the gunner's weight and convenient control mechanisms, stated the plant's report on turret trials. The distinctive feature of the hatch mount was the extraordinary simplicity of its design and its rather low weight, 12.3 pounds. The basis of the navigator's gun mount design was the requirement of quick transition of the navigator to firing. Distinguished by a special construction scheme, the mount was a major step in the design of special high-speed aircraft armament. Its distinguishing features were the very high rate of fire for the time, about 3,500 rounds per minute, and its low weight. Preparation of the main Gorbanov plant for SB production began as early as the spring of 1935. At the same time, under Klimov's leadership, work was underway to launch into series and improve the Hispano-Suiza 12Y engine, which received the designation M100. Compared to the prototype, serial SB aircraft had an increased wing area of 610 square feet and a normal flight weight of 12,400 pounds. Their maximum speed at rated altitude was correspondingly reduced and equaled 244 miles per hour, while the time to climb 16,400 feet increased to 11.7 minutes. The range of serial aircraft with a bomb load of 1,100 pounds could reach 1,359 miles at an overloaded flight weight of 14,020 pounds. Takeoff and landing characteristics allowed operation from small field airstrips. Their takeoff, run, and landing roll did not exceed 980 1,150 feet. With snow cover deeper than 12 inches, the aircraft were equipped with retractable skis, in which case the doors covering the retracted wheel gear bays were replaced by special fairings made to the contour of the retracted ski. The use of ski landing gear reduced maximum flight speed by 7 to 11 miles per hour, but thanks to the skis, the high combat readiness of SB aircraft was maintained in winter, which was very important in those years when there was practically no special equipment for compacting the numerous field airstrips on which SB aircraft were supposed to be based. The speed and rate of climb characteristics of the serial aircraft were improved by installing more powerful M100A engines with increased rated power of 860 horsepower at rated altitude. Already in December 1936, the SB aircraft with the new engines passed state trials and showed impressive results. Its maximum speed reached 263 miles per hour, and it climbed to 16,400 feet in only 8.6 minutes. In the autumn of 1936, at the request of the Spanish Republican government, serial SB aircraft together with Soviet pilots and technical personnel were sent to Spain. Arriving there at the end of September, these aircraft in their flight characteristics, especially in speed and climbability, significantly surpassed the best aviation technology available to the rebels at that time. They received their aircraft from the fascist governments of Italy and Germany, machines such as the Heinkel 52 fighter, Caproni 101, Savoia 81, and Junkers Ju 86 bombers. At the first stage of hostilities in Spain, SB aircraft, flown by Soviet and later also Spanish crews, carried out their combat missions without fighter escort. They operated effectively against various ground and naval targets, striking enemy troop concentrations, airfields, ports, transports, and warships. There were frequent cases when SB aircraft intercepted and dispersed enemy bomber formations in the air. To counter SB aircraft, new anti-aircraft guns with more advanced sighting and fire control devices, as well as Messerschmitt 109B fighters, began to arrive from Germany. From the autumn of 1937, SB aircraft flown by Soviet crews began taking active part in repelling the aggression of Japanese militarists against the Chinese people. The appearance of the latest Soviet-designed high-speed bombers significantly strengthened the offensive capability of Chinese military aviation, which by that time had practically lost all its combat equipment. As in Spain, SB aircraft operated in China without escort. Chinese pilots and ground personnel quickly mastered the SB and for a long time actively used these machines in the War of Liberation against Japan. Thanks to its high flight tactical characteristics, the SB became the first Soviet aircraft to be produced under license abroad. In the variant with modernized engines, Czechoslovak aviation industry built about 110 SB aircraft under the designation B-7. Which, after the occupation of Czechoslovakia, were used in the Luftwaffe of fascist Germany and its satellites. The combat experience of SB aircraft in Spain and China determined the directions of their further improvement. First of all, combat sorties revealed the vulnerability of the SB from the rear hemisphere. The gunner's canopy, which fit into the theoretical fuselage contour, restricted the gunner's rearward view, and preparing the upper turret for battle required some time, which was sometimes lacking in aerial combat. Moreover, the combat conditions of the gunner, forced during battle to expose himself to the airstream, left much to be desired. Observation of the lower rear sector beneath the aircraft, from which enemy aircraft mainly attacked, was insufficient, and the hatch mount designed to repel such attacks had very limited firing arcs. Based on combat experience, pilots also demanded an increase of the bomb load from 1,320 to 2,643 300 pounds. The SB aircraft, with modernized engines and improved defensive armament, passed state trials in May-June 1937. The new defensive armament significantly strengthened the aircraft's defense against enemy fighter attacks, especially from below and behind. Tests with simulated aerial combat showed that the new hatch mount provided 2 to 3 times more hits on target than the previous one. The flight performance of the SB with new turrets decreased insignificantly. The SB with new turrets had a maximum speed of 256 miles per hour at an altitude of 13,100 feet. The new defensive armament was slated for introduction into serial production, but until 1940 it was installed only on selected SB aircraft that were expected to fly in the rear of bomber formations. Only after the Soviet-Finnish War were the old turrets of SB aircraft widely replaced by new ones, but time was lost. and the majority of SB aircraft in the first period of the Great Patriotic War fought with outdated defensive armament, whose capabilities German pilots had already studied well in Spain. Tests of the SB bis aircraft were conducted between September 1937 and March 1938. The installation of new engines significantly improved the flight performance of all three experimental aircraft. On September 2, 1937, pilot Mikhail Alexeyev, flying the first SB bis, set an international record by lifting a payload of 2,200 pounds to an altitude of 40,200 feet. The highest speed performance was demonstrated by the SB bis of the third modification with tunnel-type water radiators, which reached a maximum speed of 276 miles per hour at an altitude of 14,800 feet. Pilots also noted improved cockpit visibility with the installation of nacelles of the new shape. However, the tunnel radiator installation still required refinement, and for serial production, the SB bis of the second modification was chosen, with nacelles featuring frontal radiator placement. The SB bis of the second modification, with increased airframe strength, external bomb suspension racks, and fitted with an armored backrest in the pilot's cockpit, became the standard for serial production in the second half of 1938 and the first half of 1939. Thanks to the installation of external racks and streamlined fairings under the wing center section for bombs weighing 550 and 2,100 pounds, the maximum bomb load of the SB with new engines was increased to 3,530 pounds. With the normal flight weight increased to 13,600 pounds, the maximum speed of the aircraft was 260 miles per hour, while it retained the high rate of climb characteristic of the lighter variants of the SB with earlier engines. Takeoff and landing characteristics of the modernized aircraft also remained unchanged thanks to the new engines. The maximum flight weight of the modernized SB with a bomb load of 3,300 pounds and full fuel tanks was increased to 17,000 to 100 pounds, providing an operational radius of up to 370 miles. According to military specialists, despite some deterioration of flight performance at maximum bomb load, the SB with new engines still belonged to the class of high-speed bombers, and the increase of the bomb load to 3,300 pounds significantly expanded its combat capabilities. With the introduction of SB aircraft into serial production, the Soviet aviation industry continuously increased production rates, and in 1937-1938 the factories produced up to 13 SB aircraft per day. The mass rearmament of bomber and reconnaissance units with the new aircraft required the creation of a training version of the SB. This task was first attempted in autumn 1937 on the first SB bis, equipped with a navigator's cockpit with dual controls. However, tests showed that the new cockpit hindered the navigator's work and worsened the aircraft's aerodynamics. In March 1938, a training version of the SB, fitted with an open instructor's cockpit instead of the navigator's cockpit, was presented for state trials. The cockpit had dual flight controls and all necessary instruments for the instructor. The design allowed the cockpit to be installed instead of the navigator's cockpit in operational Air Force units. The aircraft passed state trials and was built in a small series under the designation USB Crew. Continuing to improve the serial combat SB aircraft, Alexander Arkhangelsky's Design Bureau in 1938-1939 developed a number of innovations that enhanced the combat and operational effectiveness of the SB. These included self-sealing and fiber fuel tanks, which improved the aircraft's survivability in combat, and drop tanks with a capacity of 97-98 gallons each, mounted on external racks under the wing center section. Work also continued on improving the SB's armament. In the summer of 1938, the SB was tested with 10 rocket launchers, i.e., launchers for firing rockets mounted under the detachable wing sections. The launchers successfully passed flight and military trials and were adopted by the bomber aviation arm. However, this powerful weapon for the time, intended primarily for attacking ground targets, was practically not used in pre-war years for training flight personnel. Only 6 SB aircraft in the winter of 1939-1940 were equipped with rocket launchers and used during the Soviet-Finnish War. The AN-T-46 was a 2-seat fighter with 2 1.8-inch caliber cannons in the wings near the ailerons, structurally a lightened version of the SB with 2 French engines. Design work began in November 1934, and the first flights took place on August 9-13, 1935. The aircraft passed factory trials by June 1936. This fighter was never submitted for state trials. In addition to bombers, a number of ANT-40 aircraft were also produced in a postal cargo version. These received the designation Penny 40. On these aircraft, a group of Aeroflot pilots first mastered flights at high altitudes.